Hi, this lesson is about the characteristics of a quadratic function and its graph. So a quadratic function looks like this in its standard form, where y equals ax squared plus bx plus c. The term that makes it quadratic is the ax squared term. If you didn't have the ax squared term and you only had the bx and the plus c, then it would be a linear function. So you can be missing the bx term and even the constant and both, but you can't be missing the ax squared term, the one that makes it a second degree polynomial. The graph of a quadratic function is called a parabola. So that's the way it's spelled, Parabola. The parabola is going to have somewhat of a U shape, and the direction of that U will depend on what A is, the number in front of the x squared. So when A is positive, a number greater than 0, your parabola faces upward. So it would be something like this. So it's not a traditional U, the way you think of it, where the two sides kind of just go vertically. The beginning and end keep opening up. So this actually keeps getting wider and wider as this continues going upward forever and ever. So just keep that in mind. And you want the bottom part of it to be rounded the way you see here. It should not look like a V. So that would not be correct. Okay, so when it's facing upward, the lowest point on the graph, which would be the one where this kind of curve happens, this is called the minimum value or the vertex of the parabola. The vertex is always an important point that you should always find whenever you're asked to graph a parabola. The parabola could also be an upside down U shape, and that's when A is negative. When A is negative, it will look like the reverse of what I drew above. And again, this kind of keeps opening upward as it keeps, as the graph just keeps going in both directions. But again, for limited space on graphs and stuff, we just put arrows to indicate that it goes on and on forever. The high point, or this point where the graph turns, is called the maximum value, and the maximum value is also called the vertex. So whether the graph is facing upward or downward, this point, this special point where the transition happens, where the turn happens, is called a vertex. To find the vertex, we use a formula, and the formula is right here. The vertex is a point, so it needs an x and a y value. So the coordinates are negative b over 2a, comma, f of negative b over 2a. And that's where x is the negative b over 2a, and you get the b and the a from here, from the original function stated in standard form, ax squared plus bx plus c. And the y, you get the y by plugging in this number into the function and then evaluating for y. Okay, so in addition to a vertex, which again is a very important point to find, you're also going to want to keep in mind something called the axis of symmetry. So again, for convenience, sometimes I abbreviate this as AOS, so I don't have to keep writing axis of symmetry. An axis of symmetry is a vertical line that passes through the vertex. The equation of the axis of symmetry is x equals negative b over 2a. So that's how we state vertical lines, x equal to a constant. And that constant, negative b over 2a, well, it's no coincidence that it's the same number we found here to find the vertex, because it passes through the vertex. And for practical reasons, the axis of symmetry isn't really part of the graph. It's usually drawn as a vertical line, just so that you could visualize it. But what it does is it splits the graph in half so that the left side and the right side of the graph are mirror images of each other. And sometimes that's very convenient to help you find additional points on the graph for you to plot the curve. Other points you should look for are intercepts. So let's talk about the Y-intercept first. You find the Y-intercept by letting x equal 0. And since our function is y equals ax squared plus bx plus c, when x equals 0, your y-intercept is going to be 0. So remember, these two will then go away. And so your constant will be the value that you're left with. So your y-intercept is just going to be 0c. You find your x-intercepts by letting y equal 0. And since y is equal to 0, you're basically going to be solving a quadratic equation. And so now we have to go back to skills we've learned in the past. To solve quadratic equations, sometimes we can factor them. And if it's factorable and the numbers are reasonably small, that's usually the quickest way to find your x-intercepts. But if it's not factorable, we can find x-intercepts possibly by the completing the square method or the quadratic formula. And in some cases, depending on the format of the equation, you can use the square root method. If the solutions to ax squared plus bx plus c equals 0, if they are real numbers, meaning not complex, no imaginary numbers, then you have found the x-intercepts. But if your answers are imaginary, you cannot graph an imaginary number or a complex number on an xy plane. So if you happen to get solutions to this equation where you have i's in your solution, they're not going to help you to graph the function. There'll be solutions, but they won't be x-intercepts. All right, so let's do a few examples. Here's the first example in blue. Identify the vertex, the y-intercept, and the x-intercepts, then sketch the graph of y equals x squared minus 6x minus 7. So in this equation, my a is 1, my b is negative 6, and my c is negative 7. So when I look for the vertex, remember x is negative b over 2a. So that's negative negative 6 over 2 times 1, which gives me an x value of 3. To find the y-coordinate, because you always need an x and a y-coordinate to plot a point, then you take 3 and you plug it into your function. And by the way, this is your function, x squared minus 6x minus 7. So when you compute that, 3 squared minus 6 times 3 minus 7, we get 9 minus 18. That's negative 9 minus 7. I get a vertex of 3, negative 16. I know that's going to be my minimum point, the lowest point on the graph, because my leading coefficient is positive. So it has to be an upward facing U shape. Y-intercept. Y-intercept is when x equals 0. So those are always easy to find. When x is equal to 0, if you plug it into your function, you're going to get the constant, as I mentioned before, which is negative 7. So your y-intercept is 0, negative 7. So that's a point that you would want to plot. X-intercepts. That's when we take our function, x squared minus 6x minus 7, and set that equal to 0. This one is factorable. So two numbers that give me a product of negative 7 and a difference of negative 6 are the factors x minus 7 and x plus 1, giving me two solutions of 7 and negative 1. So be careful, because sometimes I see students say that their point is 7, negative 1. That doesn't make sense, so that is not correct. Your points are right here. Your points are negative 1, 0, because remember we let y equal 0, and 7, 0. X-intercepts exist on the x-axis, so the y value must be 0. All right, so everything I just found in these 3 boxes are now seen on this graph. Here's my vertex, 3, negative 16. Here's my y-intercept, 0, negative 7. And here are my 2 x-intercepts, negative 1, 0, and 7, 0. And when you connect that from left to right, you get your parabola. It's your traditional U-shaped graph for a parabola facing upward as we expected. Okay, here's another example. Identify the vertex, the axis of symmetry, the Y-intercept, and the X intercepts, and sketch the graph. So it's similar instructions, except here I'm also asking for the axis of symmetry. All right, so our graph is 8 minus 2x squared. So first, let's find our vertex. So A is negative 2, B is 0 because I don't have an x term here, and my C is the number 8, positive 8. So when you plug into your vertex formula, x is negative b over 2a, so that's 0, negative 0 over 2 times negative 2. Well, 0 divided by negative 4 is definitely equal to 0. And when x is equal to 0, you plug it into your function, which is what you see here, and you get that the y value is 8. So my vertex is 0, 8. Now, I know my vertex is going to be a maximum value, a high point on the graph, because my A is negative, so my graph should be upside down. So always try to keep in mind things that you know to kind of guide you in the right direction. Once you calculate your vertex, you can easily find the axis of symmetry. I'm abbreviating that as AOS. And your axis of symmetry will be whatever you computed right here when you computed your vertex. So since the x-coordinate of the vertex is 0, my axis of symmetry is the vertical line x equal to 0. And by the way, x equal to 0 happens to be one of the axes. This also happens to be the y-axis. Okay, y-intercept. The y-intercept is when x is equal to 0. Well, coincidentally, my y-intercept is also my vertex. So far, I only have one point to plot. X-intercepts. We find x-intercepts by letting the function equal 0. That's what you see here. The format of this equation is a good candidate for the square root method. So I add 2x squared to both sides. Then I divide by 2. So I'm left with 4 equals x squared. When you take the square root of both sides, you get two solutions. X is equal to plus or minus 2. Okay, so those solutions represent intercepts. And so my x-intercepts are negative 2, 0, and 2, 0. So I have 3 points to plot. My vertex here, which is again the maximum value, the greatest value on the function, and my two x-intercepts here, negative 2, 0, and 2, 0. And I'm going to show you where the axis of symmetry is. Axis of symmetry, I'll put it here in this bluish green color. This is the vertical line that splits this parabola in half. That's why the distance from the center, from the axis of symmetry to here, this is 2 units. And the distance from here to here is also 2 units. So axis of symmetry can actually help you find points anywhere along the graph because the distance from one side to another will always be consistent. All right, so let's do another example. So here in green, identify the vertex, the axis of symmetry, and the intercepts, then sketch the graph of f of x equal to 2x squared plus 5x minus 3. Okay, so as I mentioned in the previous problems, you want to identify your A, your B, and your C so that you can plug into your vertex formula. And again, I just want to note my A is positive. I expect my graph to be upward facing, an upward facing U. Okay, so my formula for vertex is here. X is equal to negative B over 2A. So that's negative 5 over 2 times 2. That gives me a value of negative 5/4. And for graphing purposes, you're going to want to know that that's negative 1 1/4. So it's a little bit past negative 1, between negative 1 and 2, but closer to negative 1. Then you need to plug in negative 5/4 into your function, which is this one here, and that's the work you see here. You have to take 2 times negative 5/4 squared plus 5 times negative 5/4 minus 3. So square and multiply, so that's what you see here. I have 2 times 25/16 minus 25 over 4 minus 3 over 1. And then here I simplified the 2 and the 16, so I get y equals 25 over 8 minus 25 over 4 minus 3 over 1. Then I get an LCD, lowest common denominator of 8. So you get 25 over 8 minus 50 over 8 minus 24 over 8. That works out to be negative 48 over 8. And again, for graphing purposes, you want to rewrite that as a mixed number. So 8 goes into 49 6 times, and you have 1 left over. So your vertex is negative 1 1/4, negative 6 1/8. That means that your axis of symmetry is also at negative 1 1/4, which is the same as negative 5/4. Remember, these two numbers are equivalent. Okay, so now we need to find our y-intercept. Y-intercept should always be the easiest one to find. That's when x is 0. And when x is 0, the first term goes away, the second term goes away, so you're just left with negative 3. Just get rid of those two lines. So 0, negative 3 is my y-intercept. Now we need to find our x-intercepts. X-intercepts is when you let your function equal 0. So this one is also factorable. So the two factors that will give you that polynomial are 2x minus 1 times x plus 3, which means I get two solutions, x equal to a half and x equal to negative 3. So I have two y-intercepts at negative 3, 0, and at positive 1/2, 0. All right, so let's put this graph together. So here's my vertex right here. Negative 1 1/4, negative 6 1/8. You go to the left between negative 1 and 2, and then down just a little bit past negative 6. Then we have our y-intercept at 0, negative 3. That's right here. Then we have our two x-intercepts at negative 3, 0, and at 1/2, 0. You connect the points from left to right to get your U shape, and you've got your graph. All right, so this problem has a part B, and it will allow us to revisit something that we learned in a previous module. So we want to state the domain and range in both set builder notation and interval notation. So the domain are all possible values of x, and the range are all possible values of y. Well, let's go back to the graph to figure this out. Your domain are all possible values of x. X actually could be any real number, because remember, I explained that this is going to keep opening up in both directions. So any value of x, positive or negative, along this horizontal line, this x-axis, will have a corresponding value that connects on this graph. So if x is, let's say, something over here like 5, I'm going to have some number way up here that plots onto this graph. And the same can be said of any point on the parabola. So parabolas in general will always have a domain of all real numbers, but your range will always have a restriction, and the range will depend on the direction that the parabola is going in, up or down, and the vertex. With range, you read the y values. And so, if you read the y values from bottom to top, my lowest y value is negative 6 1/8, which, if you recall, that's the same as negative 49/8. So my range goes from negative 49/8 all the way to infinity, again, because this graph is increasing forever and ever, both on the left side and on the right side of that vertex. It continues on forever. So the way we display that is here. My range in set builder notation is the set of all y such that y is greater than or equal to negative 49/8, or in interval notation, it is the closed interval from negative 49/8 all the way to infinity, and you always put a parentheses associated with plus or minus infinity. So this is our domain and range for that function. All right, so let's do another one. Identify the vertex, the axis of symmetry, the intercepts, and sketch the graph for y equals negative x squared minus 4x minus 6. So here my a is negative 1, my b is negative 4, and my c is negative 6. So my a is negative. I know my graph is going to be an upside down U. So here's my vertex. X equals negative 4 over 2 times negative 1. We get an x value of negative 2. Then we plug in negative 2 into our function, which is what you see here. So it's negative 2 squared minus 4 times negative 2 minus 6. That works out to be a y value of negative 2. So both x and y are negative 2. That's our vertex. Y-intercept, that's when x is equal to 0. So your constant is negative 6. So the y-intercept is 0, negative 6. I forgot to mention this before. That means that your axis of symmetry is also negative 2. And again, we got that from the computation of the x value of the intercept. Okay, now let's find our x-intercepts. The x-intercepts is when you let the equation equal 0. All right, so even if you tried, you can't factor this one. So we're going to use the quadratic formula. So remember, quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. So you should memorize that if you haven't already. So here's my a, b, and c, and I just plugged it in here into the quadratic formula. So we have negative 4 plus or minus the square root of negative 4 squared minus 4 times negative 1 times negative 6. Okay, so you have to do the computations inside the radical first. So you get 16 minus 24. So we end up with 4 plus or minus negative root 8 divided by negative 2. You can simplify that. And so you have 4 plus or minus 2i root 2, because remember, negative root negative 8 is I root 8, which is 4 times 2, but the 4 comes out. So it's it's 2i root 2, which is what I wrote below right here. Okay, but everything is divisible by 2. So when I divide by the top terms by negative 2, you get negative 2 plus or minus I root 2. That is certainly not an x-intercept because it is a complex number. Therefore, there are no x-intercepts for you to plot. So this is a solution to the equation. You can have solutions that are complex numbers, but you cannot plot them in order to graph the parabola. Okay, so let's go to the plotting, keeping in mind that we don't have x-intercepts. So I'm going to plot my vertex, which is right here, negative 2, negative 2. I've also shown you my axis of symmetry. That's the line, x equal negative 2, the vertical line that splits it in half. And then I have my y-intercept at 0, negative 6. So I really only have my vertex and my y-intercept. So in order to get a good picture, I should have at least one point on the other side. Now keep in mind that the axis of symmetry, as I mentioned before, splits the graph in half, and the distance from one point to the axis of symmetry is the same on the other side. So there are 2 units from here to here. There's a distance of 2. So that means there must be another point on the other side that's also 2 units away. So this point here is negative 4, negative 6. So this one was 0, negative 6. And in the middle, we were at negative 2. So you can easily find another point by using the concept of what an axis of symmetry is. All right, so we're going to, again, find the domain and range. Domain should be easy by now because domain for parabolas will always be all real numbers. So with set builder notation, it's the set of all x such that x is an element of the real numbers. So this is an R, it kind of has like a double line in front of it, like a fancy R. Or in interval notation, it's the interval from negative infinity to infinity. Now my range. My range, you really need to graph it in order to say what the range is. It makes it easier to read. You read your graph from bottom to top. So remember, again, these arrows mean that this graph is going towards negative infinity. And then it increases all the way till we get to this vertex. And remember, the vertex here is -2, -2. When you're determining the range, you're reading the y value, the second one. And so my range is the set of all y such that y is less than or equal to -2, or the interval from negative infinity all the way to -2, and you put a closed bracket around -2 because -2 is an actual point on the graph. Okay, so now you should be ready to do the homework for this section. Good luck.